Hello everyone, this is Miss Hanley, and today we're going to talk about solving systems of equations using elimination. You've already seen solving systems by graphing, solving systems by substitution, and solving systems by elimination is the third option we have. You can use either of the three methods and always come up with the same answer. However, there are situations when one may be easier than the other. So let's walk through a few examples of elimination. You can follow along in your foldable, and this first one is a one solution. So we're going to look at these two equations. 5x plus 3y is equal to negative 19, and 8x plus 3y is equal to negative 25. Now when we think about the word elimination, we're trying to eliminate a variable. And you can eliminate either x or y, but in order to eliminate them, we have to get them to equal 0. So when we start, we want to make sure that our equations are in standard form. And if you remember standard form, that's your ax plus by is equal to c, right? As long as we have that set up, we can go ahead and cancel one of our variables. So we need to either add or subtract two lines that we have together, and one of the variables has to equal 0. So in order to do that, there are two things you're looking for. One is you want the same coefficient in front of your variable. So if you look at the x's here, I have a 5 and an 8. It's going to take some work for them to actually cancel out. So rather than cancel 5 and 8, what we're going to do is we're going to look at the y's and say, okay, well, if I look at the y's, we have 3y and 3y. They're exactly the same and have the same coefficient. So in this case, we can cancel our y's. That will be easier to get to 0. And I want to think, do I have to add these two together to get 0, these two lines? Or should I be subtracting these two? Which of these will give me 0 with my y? Well, 3 plus 3 is going to give me 6, and that doesn't help. So instead, we want to subtract. And when you subtract your two lines, what I'm going to go through and do is, since you're subtracting one from the other, rather than try and remember to carry that subtraction through, I'm going to change all of my signs. So I'm going to distribute that negative through just like you would anything else. And this is going to become negative 8x plus a negative 3y plus 25. Now you're essentially adding your lines together. So let's see, 5x minus 8x is going to give me a negative 3x. 3y minus 3y is going to give me 0. So we could use plus 0. It's sort of unnecessary. So I'm not going to write it. And then out here, we have negative 19 plus 25, which is 6. Now you only have one variable. You guys know how to solve that. So we're going to take and divide. So we get 6 divided by negative 3, which is a negative 2. Okay. Well, we have an x, but remember when your two lines intersect, you're looking for a full point. So if I know x is equal to negative 2, I want to go back and find my y value. So you can pick either of the equations, but go back to your original equations. So we have 5x plus 3y is equal to negative 19. That was my first. I'm just going to go ahead and use that. I know x is equal to negative 2, so I'm going to take this x value and replace it with that, for that. So we would have 5 times negative 2 plus 3y is equal to a negative 19. Gives me negative 10 plus 3y is equal to a negative 19. Adding 10 to both sides, 3y is equal to negative 9, or y is equal to negative 3. So the solution to my system is negative 2 negative 3. That's the point where those two lines would intersect. Next, we want to look at a set where you have two equations, and we know that they're both in standard form. But if I look at my coefficients here, if I look at the coefficients of the x's, two different numbers. If I look at the coefficients of the y's, those are two different numbers. So there's no way I could add or subtract these together in order to get 0. Sometimes you have to multiply to cancel out a variable. But we can multiply every single piece of our equation, just like we could divide every piece of our equation. And we're not changing the line, we're just changing how it looks. Almost like manipulating fractions. So let's say I want to cancel my x values. I notice that 1 is 5 and 1 is 10. Well, I look at the larger one, and you want to think, what do they both go into evenly? Well, I know 5 goes into 10 evenly, and 5 goes into 10 twice. So I am going to take and multiply my top equation by 2, and I'm going to multiply all the way through. I would also maybe multiply through by a negative 2, and the reason being is that I want my variables to cancel. I want to make 0, and if the bottom is positive 10 and the top will be a negative, then they will add to get 0. So we're distributing this through, so we get negative 10x minus 6y, and that's equal to negative 104. Now I want to add straight down. 10x minus 10x, that's 0. That's gone. 6y minus 6y is also gone. And 104 minus 104 is gone. So we're left with 0 is equal to 0. Well, if 0 is actually equal to 0, which I think it is, that's a true statement. So this is a situation where you would have infinite solutions. Okay, which means that you have two equations making one line. They make the exact same line. The third example here is an example of a no solution. So let's watch what happens. First, check your steps. Well, are my equations in standard form? Yes, they are. So my second step is to add or subtract the lines together to eliminate x or y. If you look at the coefficients on your x's, they're both the same number, which is a good thing. So right now, 5 minus 5, if I just added those together, we would get 0 without having to do much work. You can also notice that the same thing is happening with your y's. You have positive 6y minus 6y. Again, that's going to give us 0. But let's add them together and see what happens. Well, 5x minus 5x, 0. 6y minus 6y, 0. And 45 plus 38 gives me 83. Well, is 0 equal to 83? No. And since that's false, we have no solution. So those are the three different situations you can encounter. Again, remember, you may have to multiply to do some elimination, but you may be able to just add or subtract. You still can get one solution, no solution, or infinitely many solutions.